Hi, we're going to be looking at equivalent fractions today, and we have another special guest.
Hi.
Yep, that's our special guest. So he's going to help me out today, and we're going to look at equivalent fractions. We're going to look at how we can see numbers that we may not see initially. So right now, what do we have? Special guest.
One whole.
We have one whole. He sees one whole. I see a fourth up here, and I see another fourth. Do you see that as well?
Yes.
And I see a fourth over here, and I see a fourth over there. So if we put all those together, what do we have?
We have one whole.
We have one whole. He sees one whole. I see 4 fourths. Are those the same?
Yes.
Very good. So when we have the numerator and the denominator the same, 4 over 4, 5 over 5, 6 over 6, we have one whole. Is that correct? Good. Well, now we're going to look at how we can make some equivalent fractions out of our numbers. So I'm going to go ahead and delete these two portions. And what did I just delete?
1/2.
He said a half. I saw 2 fourths going. Did you see 2 fourths?
Yes.
Leave? Well, I'll tell you what. Let's write that down and let's find out how 2 fourths and 1/2 might be the same number. So we have a rule in math that says I'm allowed to do something to one side of my equation as long as I do the same thing to the other. So what do you think I'm going to do to my numerator?
You're going to subtract it by 1.
Well, good guess. In this particular case, I'm starting a division, aren't I? So what do you think I'm going to divide that numerator by?
Half.
Good. I'm going to divide that numerator by 2. I'm going to divide 2 divided by 2. What do you think I'm going to divide my denominator by?
2.
I have to, don't I? Because whatever I do to my numerator, I have to do the same thing to my denominator. And then what we have is 2 divided by 2 equals 1. 4 divided by 2 equals 2. And that's how we got 2 fourths equals 1/2. Okay, we took a pause and we're back. So now what we're going to do is we're going to look at a couple of other fractions and we're going to see if we can make the same thing hold true with some other fractions. Let's get rid of this. We don't need that anymore. So let's see if we can take a fraction like, say, 8/24 and find an equivalent fraction. Let's go ahead and make these numbers larger first. So what do you think we should do to this fraction? What can we multiply it by to make an equivalent fraction?
Times 2.
Go ahead and write that. Good. Now, if I multiply it by 2, isn't 2 really 2 over 1?
Yes.
It is. So really, won't I multiply it by a whole? Or 2 over 2?
Yeah.
Yes. So now what would 8 times 2 be?
16.
16, and then 24 times 2
48.
is 48. You're pretty quick. So we're saying that 16/48 is equal to 8/24. So you think that's true?
Yes.
Well, let's test it out. Let's take 16 over 48 and let's divide by 2 over 2 and see what we get. What's 16 divided by 2?
8.
And 48 divided by 2.
24.
And look at that. We got the same answer here that we started with there. The problem is we need to reduce this fraction rather than make it larger. We need to bring it to its simplest form. So we need to divide 8/24 by a factor that 8 and 24 have in common. Can you see a factor that they have in common?
Yes.
What factor?
2.
2 is great. Go ahead and divide it by 2 over 2. Okay, go ahead and divide. And we get 4 over 12. Now, do 4 and 12 have a common factor? A factor in common?
Yes.
They do, don't they? Let's switch colors. What is the largest common factor that 4 and 12 have?
3. Wait, no, I meant 2.
Okay, 2 is a common factor, isn't it? Go ahead and divide it by 2 over 2. Now let's bring 2, 6 down here because we kind of ran out of room. We're going to bring it over here, 2, 6. And tell me something. Is that as reduced as it can get, do you think?
No,
How did you know?
because one goes into both of them.
One will go into all of our numbers, won't it? That doesn't
Yeah.
help us. It doesn't help us reduce it, does it? It won't shrink it down any.
No.
We divide by one, we get the same exact digits. So, what do you think we can, is there a factor that 2 and 6 have in common?
2.
2, so we can divide it even further. So 1/3. Now you've got 1/3, and I'm going to go ahead and circle that, and let's look at 1/3. Do 1 and 3 have any common factors greater than the number 1?
No.
So 1 is the greatest common factor for 1 and 3. When that happens, we've reduced our fraction all the way. Now let me show you something. We reduced 8/24ths to 1/3, didn't we?
Mhm.
We could have taken 8/24ths. Let's go ahead and erase all this. We could have taken 8/24ths if we knew at that time that 8/24ths, the greatest common factor between 8 and 24 is 8. 8 goes into 8, and 8 goes into 24, doesn't it?
Mhm.
If we knew that, look how fast this would have been. 8 divided by 8 is 1. 24 divided by 8 is 3. We got there either way, didn't we? So we got to the same answer. So let's try this one. Let's try, how about, let's try 8/27ths. Now, we're going to look at this and see if we can reduce it. Any ideas? We have to look for a common factor for 8 and 27, don't we?
Mhm.
What are some factors of 8?
2 and 4. 1 and 8. Yeah.
And that's it. 27. Is 2 a factor of 27?
No.
So 4 wouldn't be. And 8 wouldn't be. We're stuck, aren't we?
Mhm.
Now, 27 has 3, but oh well, right? And 9, that
Yeah.
doesn't help us, does it? So what do you think the greatest common factor between 8 and 27 is? The largest number that goes into 8 and 27.
Well, 1.
That's it.
Oh, 1.
When the greatest common factor is 1, we've reduced our fraction. We can't reduce that one. Okay?
Oh.
Does that make sense?
Mhm.
And then I've got a really tricky one, and I'm glad you're here for it because it will make it really nice. Are you ready for a hard one?
Yeah.
You sure? See if you can figure this one out. Is that one reduced?
Let's see.
I'm going to help you think out loud so people can hear us. So, how many factors does 7 have?
7 has 1.
And
1 and 7.
1 and 7. So it has 2 factors. 1 in itself. So 1 is a factor that's not going to help us, is it?
Mhm.
So let's look at 7. That's the only other factor for 7. So 7 goes into 7, doesn't it?
Mhm.
Does 7 go into 91?
Let's see.
We don't know, we can't get there a shortcut way, can we?
Mm-mm.
Because 7 doesn't really have a rule for us to use. Oh, okay, so now we have to see if 7 goes into 91, right?
Mhm.
How would we do that?
We do 91 divided by 7.
There you go, over here. Try that again, let's see if it'll work. It's playing with us, isn't it? 91, let me try some. I don't know why that just worked. There you go.
Let's see. 7 goes into 91. 7 goes into 21 3 times.
So 7 goes into 91 evenly, doesn't it? And so if we divide by 7 over 7, go ahead and do that for us. Divide by 7 over 7 equals and circle it. 1/13 is the same as 791. 7 over 91. Great job. Thank you for helping. And we'll see you